I'm Shelby Schumacher. I'm going to be reviewing and explaining Madison's 3-31 example. This is my solution to this windshield here with ice on the outside because it's cold outside, and then you blow hot air on the inside to melt that ice. You're asked to find the heat transfer coefficient for the hot air on the inside, and you're given all of these values for the system, and you can assume that it's steady state, one-dimensional, K is constant, and that there's negligible heat transfer by radiation. The first thing I did was draw out the resistance network, and for this system you have convection on the inside of your car, and then there's conduction through the glass and convection again on the outside of your car. And I started to solve this problem by writing out the heat transfer rate equation for convection, and then there's not really enough information about the windshield to find the surface area, and so I divided that over and solved for the heat flux. And then I used that total value to find the total resistance throughout the system. And then since this is in series, you can add up all of the resistances, which leaves these equations. And since we're asked to find HI, everything else is known except for that value, so we can manipulate the equation and solve for that. And Madison and I pretty much did everything the same. The only suggestion I had for her was to maybe add the assumption that negligible heat transfer by radiation, because that wasn't in there. And I saw it a lot in the solutions, and so I felt like it was an important aspect to include in the question. But other than that, everything was the same. I labeled my temperatures a little bit differently, but we approached the problem in the same way, and I feel like our feedback process went really well. She was very open and accepting of the suggestions I had and said that it was good. So yeah, I feel like we communicated well. I overall enjoyed working with Madison. She was great. Thank you.